Awesome. Welcome, Jeff, to Build Better. Thank you so much for being here.
Great to be here.
Maybe to help our audience understand a little bit about you, could you introduce yourself a little bit and share a little bit about your experience?
Yeah, absolutely. So I've spent a couple of decades in operations leading the introduction of many new types of products in the industry, even pre-smartphones, if anyone remembers what that looks like, all the way through the kind of the smartphone era, and then many different device form factors that have kind of come off of that in the wireless world, whether it's head worn, wrist worn, the first tablet devices, a lot of firsts in the industry that I've been able to be a part of, and as well as led. And it's really opened my eyes to new experiences and new approaches to solving problems. Because when you're trying to do the first of something, you're being exposed to something for the first time, and you've got to figure out a practical approach for how to solve those problems.
Can you share a little bit about the companies you've worked at and maybe the types of teams that, like functional teams that you manage in those roles? I know you led quality at one point. Maybe just share a little bit about that.
Yeah, I've led a lot of the program management aspects of supply chain, operational aspects, engineering aspects, device or component sourcing, supplier quality, and as well as chief quality officer of both Motorola and Lenovo. And along the way, I've also worked at and with Google as well.
Awesome. Well, we're so glad to have you here. Thank you for being part of our conversation about misalignments in the supply chain, internal to organizations, external with their vendors and partners. I think this is going to be a great conversation. So excited to chat about it. Maybe as a starting point to coalesce on terminology, when we talk about brands, we mean the logos that go on the products, usually the companies that are designing them. So let's start by talking about some of the misalignments that can happen internal to the brands. What have you seen as the common misalignments?
Yeah, we usually refer to the brand as like the OEM or original equipment manufacturer. And there's several teams involved to develop a new product. Whether there's engineering functions, industrial design functions, obviously operations, marketing, program management, you name it. And some of the misalignments are just involved with having individual goal sets inside of these teams, whether it's a goal around a certain time to market window that we're trying to hit, whether it's a goal around taking our quality from this level to the next, or it's a goal around a certain set of features that need to be introduced. There can be competing goals between these teams. So I think it's healthy and important for each of these teams to kind of step back and understand what is that mission and vision inside of the company, and how's the work that they do inside of their individual teams aligned to that mission and vision.
What's an example of where those goals could be competing, like internally?
Yeah, there's classic examples around when a new product is being developed, and there's always when you're in a factory setting, an operational setting, you're always trying to optimize that product and make sure it's running through your lines perfectly from a yield perspective. It's doing what you want, from a scrap perspective, as well as are you getting the right quality at the end of the line. So there's this natural tendency to want to optimize in the four walls of that manufacturing space to kind of make everything look perfect. But sometimes there needs to be a knock on the door of like, hey, we actually have to get shipping and get some product moving. So that whole time to market versus just trying to get that product perfected, in the factory is one conflict. There's another one, which is kind of the reverse, which is, when you're designing something, a complex subsystem or a full system like a smartphone, there could be anywhere from 300, 350 unique components in a phone that the OEM develops. And if you think of each of those components as a train, and each one of those trains has a schedule, sometimes there's a tendency for that train to not leave on time. It's a nice way for me to say it from an engineering perspective, and really they're really trying to optimize their part and make sure it's doing what they want in reliability, it's doing what they want from a form, fit and function perspective. And so everybody's trying to do the right thing, But at the end of the day, there's a schedule for that train to leave. And that's a common conflict that happens, which is what level of risk are we willing to take to release and to let that train go? That's another example.
That's a great example because it reminds me of a lot of conversations we had in the late days of Watch in particular. I led product design for the first generation Apple Watch. And there was almost like a lot of wish scheduling, like XVTing and things like that around like the amount of risk in that product was massive because every piece in it was different and new and we'd never done before, except maybe the touch panel, but even then it was a really small touch panel. So I'm sure the touch team would say there was something new and risky, but it's the first time we're doing waterproof. It was the first time we like embedded an antenna in a piece of glass. Like there's a folded OLED in there. It was risk on risk on risk on risk. And there was a lot of like wishful schedules. And to the point that I think people did a service to themselves and kind of deluding themselves of like, oh, well, it's EVT, so like we got to be ready for blah, but like it wasn't ready. Do you have advice for organizations that kind of fall in, you've led program management teams. You've probably dealt with the fake schedule. What advice do you have? Like, is a fake schedule something that executives need to be hunting out, seeking out, and trying to eliminate in their organization? Or is the fake schedule something that's actually a good thing because it makes everybody run a little faster than they might have run otherwise?
Yeah, there's no replacement for detail in these discussions. So when you're going through a schedule, there's just has to be an incredible amount of detail where you're going through node to node and you're understanding, down to that level of detail of like, what's this operation? We're releasing it to the supplier in this date. How long does that operation really take? And you have to have people at all levels that are capable of drilling into that level of detail. Then you can kind of suss out, like if you have multiple examples, when you're kind of stepping through a part and you want to go 5 layers deep on a part and you find multiple examples of like, well, that doesn't make sense. Well, I'm not sure how that's going to work. Or that's when you can kind of know like, okay, there's something going on with this schedule. At the same time, there's also a constant pressure to try to do things faster than they've ever been done before. So there has to be that push pull of like, yeah, that's our standard approach, and that's what a reasonable schedule should be. But if a team or someone's going to bring in kind of a new approach or kind of a new schedule timeline to deliver something, they really have to bring in the how, like bring in the baseline, and then bring in like, well, this is how we're going to do it in half the time, versus just popping in the schedule and saying, well, we're going to do this in half the time. And that's where the detail comes in. Got
it. So should, if executives are feeling that they're getting, that detail isn't there, should they be skeptical of the schedules?
Yeah. I mean, I would go back to, asking, 3 to 4, maybe 5 different questions on a particular part and going deeper and deeper and deeper. At some point, if those questions are getting answered right away and everything kind of makes sense and aligned, well, then that there's it's a real approach. But if there's a lot of, I have to get back to you, or we're not sure how we're doing this yet, well, then that's where, the alarm bells have to go off a bit. But again, there's always that constant pressure of how we've always done it and what time frame that's been under. And then there's always this time, this pressure to do things faster as well. So you kind of have to balance both.
Great. So we were talking a little bit about how there are misalignments internally. And in my experience as an engineer, I always felt that there were some pretty significant misalignments between the R&D side of the organization and kind of operations, manufacturing side of the organization. Some of it had to do with information that just wasn't shared, and so it was perceived, but maybe not actually a misalignment. What are some actual examples or specific things you've seen that you can share about how misalignments between those two teams can actually result in bad business outcomes? And that maybe that's like delayed products, or previously you told me about this term quality spill.
Right.
What are some of the specific kinds of things that can happen when they're not aligned?
Yeah, I mean, there's that's scary, right? Because from a product perspective and from a company perspective, your financials could be at stake with that. But in terms of examples, one of them is just around that linkage between like the industrial design effort, the engineering effort, and then call it the operational aspect of like we're making the part or we're building the subsystem, so the factory side of it. And one common example is kind of developing a new, ideating on a new part or a process that's never been done before, in the industry. And that could be, something mechanical, electromechanical, electrical. There's examples in kind of all these different timeframes. But when you're trying to do that and do something new in parallel with actually delivering the entire system, that product together, sometimes when you're stacking all of that risk on top of one another, that's where you get into trouble. So we used to kind of have a term for like unobtainium of like, well, we've ideated on something or a finish or something that just nobody knows how to do at this point. So there's a controlled approach. There's a way to approach those types of challenges. And the first thing you want to do is identify them. Sometimes they actually go unidentified in a product, and all of a sudden we're going to go get that part made, and like, well, we can't hold that color, or we can't hold that certain finish, or we're not going to be able to hold those specs or tolerances on this part. So the first thing is actually knowing. It's kind of the first step is like knowing you have a problem. The first step is admitting or knowing that this is something new that we've never actually approached before as a team. And that's the first thing we do is like, is this new to us? The next thing is this new to the industry? Because it may be new to us, but it may not be new to the industry. And that's where you go and you can seek out technologists on contract or different players in the industry that you bring in to help you bring that part, into reality. It's just a couple of different examples.
We had an interesting experience where we were working with an organization where part of the operational team for development in NPI was the same people that were going to be the operational team for production for that product. It's not super uncommon, but it seemed it's a little uncommon, I guess. And one of the things that we noticed is that when that operational team was in the NPI mindset, wearing the NPI hat, it was gung-ho on like quality, yield, getting the yield up, getting quality up, getting the speed up, getting ready for production, working really closely with engineering. And then as soon as the product went into production and that NPI hat came off and the NP hat came on, the same individual who is all gung-ho about quality was now around like, oh, we could ship that. Oh, we could ship this. Or like, oh, we should remove this testing or this piece because like we don't need that. That's just extra headcount, extra cost. And it was so interesting because it's literally the same person, just in those two different roles. I'd love your take on if I kind of experience that as like a broader thing from my own perspective as an engineer of like, that's kind of what it's like to be on the engineering side. That's kind of the outside looking in at ops. But you were on the other side. Maybe either, what do you see? Does that resonate at all? And if not, like, what do you see about kind of the engineering side that's misaligned from the goals of the operations side?
Yeah. So kind of, there's a lot to unpack there, but
all right, that's a long question.
Yeah, no, it's a great question, and it's really all around priorities. And what I've seen that in my experience in the past, and I've been a part of that as well. And I've actually worn both hats for the company of owning, how many million devices will be available at launch, and also owning the end-to-end quality experience and failure rate and total quality experience for that product. So it's kind of like the accelerator and brake. It's the accelerator and brake analogy. And what I try to do with my teams in that situation, what I think that helps is I have this concept of commingling goals or having some goals that actually have two ends of the goalpost. So for example, your goals can't just be to get as much supply at a certain date. So time to market supply, and so forth. You've got to have a counteracting goal around how that device performs from a quality perspective in the factory, or how that device performs in the field. So if you've got a goal to accelerate from a supply or from a volume or a time to market perspective, you've got an equally weighted goal around how that device performs. So there's something that's always counterbalancing that. And if we measure our teams in kind of a counterbalance mode there, I think you get great outcomes. I've got several examples of this as well, getting even more specific around, again, having kind of the quality efforts and the kind of the scaling efforts together. I've actually motivated and put goal sets around my reliability and quality teams to accelerate our test plans and our test profiles, not reducing the test coverage, not reducing what we do, not reducing our failure rate goals in our devices. In fact, improving those goals, but really trying to accelerate how long it takes our devices to go through testing. Because guess what? If we can test faster, we can find defects faster, and we can introduce the solution faster. On the other side of that, when I look at my program management and ops teams, my teams focused on scale, I would also give them a goal around how long does it take us from the time we identify a quality issue. Let's say it's that first analysis of those devices from the field that come back, the first devices. There's a term that many companies use for that. There's a timeline for that from the time we identify an issue to the time we actually roll the new production solution in the factory. I would put that quality goal of accelerating that timeline from identifying the issue to getting the issue rolled into the factory. I'd put that on my PM and ops teams. So when we have the two teams sitting together, they kind of know, the quality team knows that the PM team is focused on accelerating quality solutions. And when the PM and the ops teams know that the quality team is focused on accelerating the product through test, everybody can kind of look at each other and feel good about the work they're doing and how they're sharing their goals.
Yeah, and that they're working together.
Right.
What's a best in class time between identifying something in those EFFA, early field failure analysis, like the first batch back, and actually rolling a fix in? Like, what's best in class? Like,
so sometimes it can be within a day. If it's a process change in the factory, if it's something we want to put on the line, that minute, it could be a spec change on the line. You'd actually, from the time of identifying that issue that day, maybe it's something you're analyzing in the US that night. You're on the phone or you're changing code remotely and you're updating specifications on the line. So it can be within a day. Sometimes if there's a part design change, that could be different based on, the part type. But you're really focused on how many devices, first off, do you need to pause your operation if it's serious enough? But if it's not, you're really focused on how many devices are going out that way and what the predicted failure rate would be versus the money you're investing to accelerate the fix or the change. And that's the balance that you're looking at. But when you have those goals on the team like that, where the PM and the sourcing and ops teams are focused on accelerating that timeline, they're naturally looking for ways to do that.
That's awesome. It sounds great. The combination of those goals sounds like a great idea. I used to very much love EFFA. That was my favorite part of the process. But there's also like all of the revalidation that you need to do. But certainly if you're just going to increase the spec and tighten things a little bit while you figure it out, makes a lot of sense that you could go really, really fast. And I think engineers like me don't often think about, well, if you're building 100,000 a day or 50,000 a day, it adds up very quickly. Like your speed for getting those fixes in can add up incredibly quickly.
Yeah, we actually used to calculate that. We used to calculate how many consumers per day would be dissatisfied with this particular issue. And it makes it real, right? Because these are real people. These could be your neighbors. These could be, people and it makes it real and it motivates you to fix it as quickly as possible.
Yeah, awesome. Let's shift gears a little bit and talk about external misalignments that happen between the brand, the OEM, and the contract manufacturers. Now, not every brand uses a contract manufacturer, but many of them do. So, and that's a very critical relationship. So would love to hear about some of the things you've seen there be misaligned.
Right. Contract manufacturers and OEMs, these are all good people. Everybody's trying to do the right thing in their operation. And CMs are trying to support you as an OEM. They're genuinely trying to support you. They genuinely want to do a good job. Sometimes those misalignments come just from a lack of clear communication, coming out of the OEM. So it could be something around the fact of like, look, this device, it's important that this device is out by this date and at this volume. And sometimes that's a lot of the discussion, as well as the price point of the part. So it's really around when I want it and how much can I, am I willing to pay for it? But that's where you can run into problems where again, I go back to having those aligned goals around, look, we can't just be focused on time to market, and we can't just be focused on price, because guess what? We've got to deliver from a certain quality threshold perspective. So I think one of the common misalignments is just that lack of clear communication around what's important to you at that point in time when you're working with that partner. So another common thing is not understanding what's going on with your CM, what's going on with their business, how important is your product and you as a customer to that CM. That's sometimes where there's misalignment. Sometimes we want to go to the biggest CM or the most experienced CM in this place, and then sometimes we find out that we're their fifth priority, so that's a misalignment. Sometimes it's actually better to go to a smaller, scrappier CM in this situation that would make you number one, and you would get kind of the best and brightest people and focus from all the way in the top of that business. So really understanding where they're at in their business and how they perceive you is one common misalignment. If you work through that, you can make that first decision up front, which is who's my partner.
That's a great point around identifying the external factors that would influence the CM and the fruitfulness of the partnership on both sides, and thinking about like what their incentives are and what your incentives are, and trying to align those incentives. If the incentives are aligned, then there will be fewer misalignments. So one that we've seen our customers get hung up on is how people talk about and pay for rework, or identify who's going to pay for rework. Who should pay for rework? Is there a standard that everyone should have? Like, why is everybody's contract different for that?
Yeah. First off, it's important to be fair in this and really kind of look at it from both perspectives. But from an OEM perspective, the team designing the product, the brand, they have to be focused on engineering a product and engineering the manufacturing solution for that product where it doesn't fail in the factory. That's where they need to be focused on. Of course, there's going to be yield. Of course, there's going to be fallout. And once there is fallout, the question is how repairable is each subsystem in the product? How many different things do I have to touch before I get to that failing subsystem? And are they reusable, and to what level? And driving those levels up. But in terms of who pays for rework, there's got to be clear understandings up front. It shouldn't be this flat, your product costs this much and we're used to seeing this percent. So we're going to put a percent on your product times your product cost, and here's a number. That really drives a lot to me, it drives a lot of laziness and a lack of detail in the process that you don't want. You really want to get down, you actually want to drive this detail through the XVT phase and look at, where the failures are coming from, which are, design related, or which are, the design of how the product goes together in the factory related, versus what's pure workmanship. Like what's something that, you've got a fixtured solution, you've got an automated solution to build it, and it's purely workmanship. The product was dropped or scratched somehow in the factory. So you really want to be able to separate that. But it really starts with a goal that's very thoughtful and is not just around how much does this product cost and what's a normal failure rate for that type of commodity in the industry, and then your product cost times that rate is what we're going to charge you for scrap. It's got to get down to real numbers and real data on your product, and then have the brand effort focused on eliminating failure and then driving up reuse rate of every module, and then have the partner focused on the workmanship side and having kind of repeatable performance in the workmanship side. Got
it. So key takeaway, no flat rates. Nothing should be a flat rate. Because a flat rate means somebody got is able to be lazy because they won't be incentivized to try to push beyond that flat rate and get better, undercut it, get better.
Yeah, and maybe the term is just it's not nobody wants to be quote unquote lazy. It's more of like, could we have made this better? Like if we were looking at this and not just being, as the brand being okay with the flat rate, or as the CM partner being okay with the flat rate, and actually like we're actually motivated to drive, have your partner, if you're the brand, you really want your partner to be focused on that last mile of driving your yield up to your goal. You want them to actually own part of that. You don't want it to be like the yield is solely responsible on the side of the brand, and the CM will build whatever the yield is at, and whatever falls out is scrap that the brand pays. You don't want that type of situation. You want this kind of pull situation where the CM partner is actually pulling and understands that they've got to help you get to that last mile in yield, and they've got to meet your repairability rates on that product by subsystem in the product. And when you have that kind of pull, from the CM, that's when things are being optimized effectively.
What advice would you give to your younger self that you think would be helpful for people who are maybe earlier in their career, becoming leaders for the first time in this space? What's a core takeaway?
Well, I am still from the generation that grew up in a factory. So, kind of breathing that and being in that multiple hours per day and understanding the ebbs and flows of a factory and understanding how product is made, I think is critical. So if you're new to this and you're starting from the ground up, there's not a lot of manufacturing in certain geographies in this world. You really need to get out and engross yourself in the manufacturing process for days, weeks, months, and really understand how decisions are made real time, in the factory, what priorities are like, and actually see that operation, whether you're an engineer and you're designing the process for how that product's going to go together on the line, or you're the design engineer and you're designing how that part, that fit, form, function, and how that part comes into the factory, what it looks like. You really need to spend, quality time in the operation. There are advanced tools today. For my younger self, I wish we had the kind of automation, machine learning, AI, and inspection, capability that we have today. I wish we had that for my younger self. But you definitely have to spend that time, because then you can actually come back and actually develop a better process or a different approach or a way to solve a problem via machine learning or AI. But you have to start with getting that experience.
That's awesome. Thank you so much, Jeff, for being our guest here at Build Better. And we look forward to talking to you again soon.
Great to be here. Thank you for having me.